Hello everybody and welcome to today's webinar. I am joined today by Malcolm Isaacs, Clint Suave and Gasper Marino, and they're going to be talking to you today about continuous testing, the key to increasing delivery speed and quality in your DevOps pipeline. If you have any questions for any of our presenters about any of the content that they're going to be going through over the next hour, just type your questions into the questions field on your control panel and we will get to them at the end of the webinar. So now let me hand you over to today's presenters.
Okay. So, hi everyone. I'm Malcolm over there on the left, and I'm a researcher in HPE Software's digital research team. I have my colleagues here, Gasper and Clinton, both senior product marketing managers for our performance and functional testing products. You can see our Twitter handles there, so feel free to follow us and engage with us online as you wish. So the webinar itself is going to be in 3 parts. I'm going to be talking about the idea of continuous testing. Gasper is going to go into what you need to get into continuous testing. And Clint's going to drill down into a DevOps pipeline and look at how continuous testing is done in practice using one of the pipelines that we have over here in HPE Software as an example. So a few years ago, organizations they'd be ruled by the IT department. The IT department would dictate the software architecture that applications needed to follow. They'd decide what web servers they'd support, and they'd also decide what databases that they would support. And their responsibility was to ensure that the system was constantly up and that they were delivering service, good, high-quality service to the internal and external customers. But if you were developing software that had to run on the IT infrastructure, you'd have to coordinate your release with that IT department. They'd then test it extensively once you developed it, and only when they're convinced that it's not going to cause any problems are they going to be deploying it to production. And it would take a long time to release software, and that also includes deploying patches for problems that might have made their way out to the big bad world. So it would take time for things to actually get fixed. There wasn't a lot of collaboration between the teams either. The developers would work in their silos and the operations teams would work in their silos, and each of them had their own goals. But today we're in the middle of an application delivery revolution. Many applications are targeting mobile devices, smartphones and tablets, and in some cases desktop environments are coming second if at all. And developers can't allow themselves to get away with clunky or unusable interfaces that are difficult and unintuitive to use, or that are slow to respond. The cloud has also become ubiquitous. Organizations are using third-party cloud providers to host their applications, to host the software, to host the data, or to host both. There are new innovations all the time. Many of them are actually related to big data. With today's advances in computing capabilities and analytical algorithms, we can get more knowledge out of the data that we have. And one of the ways to address the speed and high quality that the market demands is to adopt a DevOps culture. And that means bringing the developers and the operations engineers together to work on shared goals, to speed up delivery and make sure that that doesn't affect quality, or at least make sure it doesn't affect it in a bad way. Now, there are 3 main drivers that we see that affect the way that we deliver applications today. So there are these new technologies coming out all the time. The Internet of Things, for example, it's bringing tons of new devices online every day, and the amount of data that these devices are generating is just staggering. Algorithms are continually or constantly evolving and developing to make sense of that data. And a lot of the technology is being delivered through new business models, such as software as a service, where service providers host applications and services, and you pay for and you use them when you need it. You don't need to worry about hosting and maintaining the infrastructure or scaling. That becomes someone else's problem. Although if you're the one that's providing that service, that software as a service, you yourself need to be able to give your customers and your users the support that they need. Developing that software is also going through a revolution with Agile and DevOps being the way that most organizations have chosen to meet the challenges of these new technologies and business models. So with DevOps being the software methodology or culture that everyone's talking about today, it means delivering software at speed without compromising on quality. An effective DevOps implementation with this continuous delivery of software, it involves the developers and the operations engineers working together to push software and to push fixes at the right time, and not just when there happens to be a window in the IT organization's schedule. So the image that you're seeing here is how we view DevOps at Hewlett Packard Enterprise. It's a never-ending cycle of continuous integration and testing and continuous delivery and deployment and continuous operations. And at the same time, we've got feedback loops in place that help us assess where we are all the time, and they allow us to make course corrections. We're looking for the things that work, we're looking for the things that don't work. We're putting time and effort into analyzing what works and what doesn't work, and we're making sure that we change whatever it is that's causing us to fail, whether that's slow delivery, whether that's too many defects, or whatever the reason might be. Wherever we can find a place to improve, that's where we're going to make the improvements. So there are a number of enablers for DevOps, but the one that we're talking about today is continuous testing. Now, the usual term that describes the path from developer to end user is pipeline. And the purpose of a physical pipeline is to move something from point A to point B while keeping it constantly flowing and constantly moving down the pipe. In a software pipeline, we've got the same idea going on. The goal is to transport code from the developer's keyboard all the way down into production. And ideally, that code is going to be bug-free, so as soon as the developer writes the code, it's going to be compiled or packaged, thrown onto the production server, and everything's going to work okay. But as we all know, in reality, it doesn't work that way, and we need to verify that the code works correctly. We need to verify that it hasn't introduced any bugs into the system. We need to make sure that the environment is configured correctly so that that doesn't cause any problems in the system. And the way that we do this is by testing the code at every stage in the development pipeline. So even before the code enters the pipeline, the developer is going to be doing work to make sure that the code works on their own machine. So they're going to be doing some testing before they actually commit their changes and their software to the main source code base. And some pipelines actually are gated in the sense that there are automatic tests that take place as soon as the developer commits code to the source code repository, and it does a double check to make sure that it compiles and passes basic tests before it actually is allowed into the pipeline. Once it gets into the pipeline, there are some very basic tests that include unit testing and component testing. If those tests pass, then we're going to be doing some more extensive testing. We'll deploy the software to a test environment. We'll have some test data, and then we'll run our tests on that. Then we'll be deploying the software to a staging area. That gives us even more extensive testing and longer running testing. Once we're confident we're going to deploy the software to production, But even then, we're not finished testing yet. We're going to be running tests on production to make sure that everything's okay, and we're going to be continuously monitoring that software in production to make sure that nothing unexpected has happened. So this is what we mean by continuous testing. It's primarily automated testing, and it's triggered by events such as check-ins. And after every set of tests runs successfully, we're going to be running more tests. So just a quick look at how one of the teams in Hewlett Packard Enterprise software describes their testing volume. They have a quick set of tests that would typically is designed to complete in 15 minutes or less. And that gives the developer an indication if there's a problem that will stop people working. So that's the quick tests that are run when someone checks something into the source code repository. If there's a problem though, or for example if the code doesn't compile, the first thing we're going to do is we're going to shut down production, or at least we're going to shut down the pipeline. We're not going to let any more code enter the pipeline because that's just going to complicate things. When you've got multiple changes entering the pipeline, it's difficult to work out which one actually caused the problem. So the developers get notified that check-ins are temporarily prohibited. The developer responsible for the change has to get involved and fix it. Usually it's something trivial. If it's not something trivial, then the developer has to roll back the change or comment out the bad code or do something quickly that will allow the other developers to continue to work. And this is really critical to the pipeline success. It's got to be kept clean at every stage. Once the quick tests have passed, then we'll move on to the full build. So that will build the changes that have been introduced since the last build in most cases. So the tests here include end-to-end tests. They're going to pass within 90 minutes. That's the target that this team has. Typically problems at this point are going to be a bit more subtle because the obvious ones are going to have been caught earlier on in the quick test or even in the gated test if it happens to be a gated pipeline. And again, if there's a problem, then we're going to shut down the pipeline until we've resolved that problem. And just as a note for developers, it sounds like a lot of pressure. And initially there is pressure on the developers, but we found that most of them get it. They might make they'll make a mistake earlier on, and they find that they've incurred the wrath of the rest of the team who can't check in code anymore. But everyone finds themselves in that position at some point or another, and people learn to do enough of their own testing before they check code in, before they commit it into the pipeline to ensure that the build won't fail. This team also has a nightly build, and they'll use it for more long-lived tests. They'll have like performance tests and security tests that can take quite a while to run. It says here that the estimated time is not applicable, but in general the teams try and complete those tests within 8 to 12 hours, which gives the team a chance to see the status of the build by the time they get into work the next morning. It also says that the status of the build here is releasable. It doesn't necessarily mean that it's going to be released at this point, but it means that it's at the level of quality and functionality that we're happy to release if it becomes necessary. I know that other teams also might have maybe a weekly build for even longer running tests, but again, the principle is the same. So there are a number of enablers for continuous testing. Sharing and communication and collaboration are crucial if a team is attempting to accelerate delivery and improve quality through continuous testing. The developers and the testers and the product owners on the team are going to be working together. They'll make sure that everyone understands in detail exactly what the product or its features and its user stories are supposed to do. One of the key goals of the initial collaboration is to agree on the definition of done. and that's going to help determine what tests need to be written. It will help determine what tests need to be executed and passed in order for the feature or for the user story to be considered complete or done. And it's also imperative that the testing is performed on the target platforms and environments. So the teams are going to be working all the time with the IT and the operations people in order to understand how the product is going to be used and deployed in production, how it's going to be secured, and how it's going to be monitored. And again, it's not a one-off event. It's continuous collaboration throughout the product's life cycle, starting from the point where testers can be performing, ad hoc testing on developers' machines to give feedback to the developers even before the code gets checked in. Continuous integration, it means that the team members are frequently checking in and committing their changes into the source code repository, and this can take place many times a day. And it's important to note that this isn't just for the product's source code itself. It also applies to the test scripts, it applies to the deployment, and it applies to the configuration instructions. Typically, checking something into the source code repository is going to start a series of automated actions. So when someone checks code in, the code is going to be merged with the main code base, and it's automatically going to be built. Once the build completes successfully, there'll be a series of short-running tests that get run. If they pass, there's a more intensive set of tests that run, and all this is orchestrated by a continuous integration server, and that shepherds the change through its different stages, from initial check-in to testing, deployment, and even post-deployment testing and monitoring. I think Gasper is going to be touching on that soon when we're talking about some of the tools that we use, and Jenkins is fundamental to us for managing the continuous integration. For automation, as most of you know, most applications today have to support multiple platforms, particularly on the client side. So you'll have laptops and desktops, and they'll be running different versions of Windows or Linux or Mac OS. And each of those are going to be supporting multiple browsers, Chrome, Firefox, Safari, Internet Explorer, or maybe even Edge. There are also mobile operating systems. You've got Android and iOS and Windows Mobile, and each of these have got their own versions as well. So these can be installed on lots of different devices and lots of different form factors. And again, as most of you know, even testing just one combination of a device, an operating system, and a browser is a huge task, and it takes a long time. So if you multiply that by the number of combinations that you need to test, if you're going to get results quickly, you have to invest in automation. And the automation is all along the pipeline. So you've got unit tests which are automated, and you've got integration tests that will be automated, and you've got non-functional requirements whose tests have to be automated, like performance or security or regulatory compliance. And there's also room for manual testing, even a continuous testing environment. I think we'll get to that a bit later, but it's usually around exploratory testing of new features. But the vast majority of tests are going to be automated in order to get to feedback quickly. And it's not just the tests that must be automated. There's also the setting up of the different environments that takes a lot of time. There's the application servers with the correct operating systems and support software. There's the web server that you need to install and configure, and then you'll need to install the application itself and configure it. There's the client machines that need to be set up and configured with the operating systems and the browsers, etc. And that takes a lot of time, and it's very error prone when it's done manually. So there's the concept of treating your infrastructure the same way as you treat your code. So have it in your source control system, have it versioned, and have it automatically run and executed whenever you need to deploy an environment. So you can configure and deploy and configure your testing environments and your production environments without any manual intervention at all. And once you've got a system in place for automatically deploying and configuring the environment, you've got a consistent testing environment. You've got a consistent deployment environment. Actually, we've begun using Docker for many of our products to kind of ensure consistent environments for our automated deploys. And lastly, we've got the concept of continuous assessment. So all this automation isn't really valuable if you don't know the results of the tests or the status of the pipeline. So if the tests failed, you need to know which ones, you need to know where they failed so that you can investigate the cause and fix it. If the build fails, you'll need to know who to contact to fix it. And if the deployment fails, you really want to know about it before your customers do. So teams will be using a dashboard that constantly updates and shows you the state of the pipeline. So everyone in the team typically has visibility into the dashboard, and it can be something as simple as just a big green or red indication of whether there are problems. But the thing is that when the dashboard is red, that there has to be a way of drilling down into the source of the failure, the reason why it's red, and finding someone who can help fix the problem. And also dashboards can provide a lot more information than just the pass or the fail status. You can also get indicators like the team's velocity, trends over time like the performance improvements or maybe deterioration, or other information that you can use to help make decisions. And just as a side note, some systems are actually implementing some predictive algorithms that can help you estimate the amount of time that it's going to take you to fix defects and get back into production, for example. So at this point, I'm going to hand over to Gasper, who's going to carry on with the presentation and talk about what continuous testing involves. So, Gasper, you should have control over the mouse at this point.
Okay. Okay. Thanks, Malcolm.
Thank you.
Can you give me control of the presentation?
Yep. You should be able to move the mouse. You can't.
I cannot do this.
Try again.
Sorry.
Try again. There you go.
Okay, perfect. Sorry. Let's go over how the pipeline works. As explained previously by Malcolm, a pipeline in its ideal form is a fully automated process that includes continuous integration and building of code, testing, deployment, and monitoring of the system in production. Here is an example of a sequence diagram of a process from one of our HPE software products. Each step in this sequence involves testing, and tests must pass in order to move to the next stage. First of all, developers start writing code and will integrate it with the source code repository. This is where code enters the pipeline. In parallel, the testers work on automating the testing from the beginning. Let's look at what happens when a developer attempts to commit some code. The developer runs a quick validation suite consisting of basic and complex validation tests that are required to pass before the code can be checked into GitHub. Within HPE software, we use GitHub as our source code management system. To automate this preliminary validation, we use the open source Evergreen plugin to prevent bad code from getting into the main trunk. Evergreen is a lightweight server-side solution for verification of Git commits. It is a gated check-in process which will not allow any failed CI commit to go into an integration, a release, or any protected branch. It keeps that process green, hence the name. If there is a problem, it alerts the developer who attempted the commit, and the developer can fix the problem without impacting the rest of the team. If the code passes this preliminary testing, it is checked into the main source trunk. When the code is successfully committed, it triggers a comprehensive build, causing the entire code based on the main trunk to be compiled, using Maven as a build tool here. Because a pre-check has already run on the code, the compilation usually succeeded. In the rare event that the compilation fails, the developer who performed the last check-in is notified and must fix the code as soon as possible. When the build fails, the trunk is locked and no more changes are allowed in until the problem has been resolved. This prevents problems from accumulating and ensures that the build and trunk is kept green. A repository manager is a dedicated server application designed to manage repositories of binary components. The usage of a repository manager is considered an essential best practice for any significant usage of a build tool. Nexus, in this case, is a Maven repository manager. You can use Nexus to host your own Maven repository for artifacts created in your company or for caching external artifacts. The most common scenario here is that now we first deploy the product to a staging area that is identical to the production environment, where we run extensive tests. If we are satisfied with the overall quality, we deploy to production at a time that causes the least disruption to the end users. The process might need to be triggered manually, but because we have adopted the concept of treating our infrastructure as code, the process of deploying is completely automatic, as is the configuration of the application and its environment. HP Coder is an infrastructure build tool that provides management and visibility of complex multi-type applications for automated release and deployment across the application lifecycle. As soon as the build is completed, Jenkins runs a suite of automated tests that have been pre-configured to run. Typical set of tests is designed to complete execution quickly so that the team gets feedback on the build's quality as soon as possible. The test suite consists primarily of API level unit and functional tests, along with some performance and security tests as well, although they must complete quickly as a rapid feedback is a priority in this case. The tests are run on a test environment which is automatically deployed after the build. As with a failed build, if the tests fail, the trunk is locked. If a test fails and the trunk is locked, it is usually the result of a serious problem that could not have been picked up on the developer's environment. Once we have made the decision to release the build, we deploy it. Some products keep the existing server and deploy the updates on a new system, then gradually migrate users to the new system. It is known as canary rollout. Other products do blue-green deployment, which involves maintaining two identical environments. In this case, the load balancer routes all the requests to one of the environments, let me say the green one, and the other environments, let's say the blue one, is upgraded. The load balancer is configured to route all requests to the blue environment, which is monitored to ensure everything works well. If so, the green environment can be decommissioned. If not, the load balancer can quickly point users back to the green environment, which is still running the previous environment. These methods ensure that we can validate that the new deployment is working correctly before rolling it out to everyone. The deployment is done via automation, and we immediately run a suite of tests after the deployment is complete. We run validations on the configuration to ensure that it was deployed correctly, and then run some critical end-to-end tests. We will also run some short performance tests to ensure that the user experience is good. By rolling out the deployment gradually, these performance tests won't affect users that are still on the previous environment environment, even if they cause the system's response to slow down. As mentioned, testing doesn't stop once a product is deployed to production. One of the first things that happens after deployment is to run a series of tests to ensure that the deployment actually succeeded. These tests include end-to-end functional tests, API tests, security tests, and performance tests. Many of these tests are automated, but we also do manual end-to-end testing in production. As long as the application is live, it is constantly monitored for performance, security, and end-user experience. Our home testing tools and application lifecycle management play a central role in a continuous testing at HPE software. In addition to our own tools, we use a lot of open source software. And in this slide, there is a quick summary of the tools and technology we typically use to enable continuous testing. HP products are in blue. Regarding the pipeline, our products use Jenkins as the continuous integration server, and our source code is managed in GitHub Enterprise. GitHub Enterprise allows us to share and reuse our source code and project across our own organization. Vergin is used to ensure that only code that compiles and passes basic tests is allowed to reach the main trunk in GitHub. We use a lot of plugins on top of Jenkins, but the most useful for our continuous testing is the HPE Application Automation plugin, which can run various functional and performance tests and report the results to Jenkins. For functional testing, we use HPE Unified Functional Testing and LeanFT for functional GUI and API testing. A very well-known option is Selenium, a suite of tools to automate web browsers across many platforms. As probably you know, Selenium runs in many browsers and operating systems and can be controlled by many programming languages and testing frameworks. From the mobility point of view, HPE Mobile Center manages the mobile device lab and allows tests to be developed and executed on both real and emulated mobile devices. Opium is an open source test automation framework for use with the native, hybrid, and mobile web apps. It drives iOS and Android apps using the WebDriver protocol. It exposes a REST API and responds with HTTP responses. For manual testing, HPE Sprinter is our tool of choice, but if you are implementing a behavior-driven development process, you need to use Cucumber that allows the execution of feature documentation written in business-facing text. Gherkin, it is the language Cucumber uses to define test case, is a business-readable, domain-specific language that lets you describe software's behavior without detailing how that behavior is implemented. Choosing Gherkin tests provides you with a methodology for transitioning from manual testing to automated testing. You can write the Gherkin tests using standard Gherkin syntax in LM Octane. For performance testing, we use all of our load and performance solutions, HPE Load Runner, Performance Center, Runner Load. An application that relies on a network must be able to react and provide manipulation. If you want to go completely open source, Chef and Puppets are the best configuration management tools. Once the application is in production, we monitor it using a number of different tools. User experience and performance is monitored using the HPE App Pulse suite, and HPE App Defender employs the runtime application self-protection to shield the application from attack and protect its data. If issues arise, HPE's Service Anywhere is always on call to handle incidents and route them to the support and development staff to resolve.
So
now, sorry.
So I will. I think I'm going to be handing over to Clint now, right?
Yes, you're right. Thank you.
So Clint, I will just make sure that Clint, you should have control over the keyboard now.
Okay.
Yeah.
All right. All right, well, thank you, everyone. Again, my name is Clint Sproff. I'm the Product Marketing Manager for Functional Testing. And what I'd like to do is quickly kind of go over some of the key components of continuous testing, but also kind of give you an idea of just how you will be able to implement this in your environment within your company. So what I'd like to do is just kind of go over those key components and kind of relate to not only how we do it within our R&D at HPE, but to also give you the options to understand what are the different choices that you have in terms of how you can implement continuous testing in your environment, because it's going to be different for every company and every industry or vertical that you may be a part of. So the three key areas we're going to concentrate on for this particular segment are real-time analytics and dashboards, the QA engineer skill set, which is very important. We'll talk more about that, and then of course the fast-paced environment. And with that, and we just talked about some of these items in terms of short releases, multiple environments, frameworks, and all the continuous components within continuous delivery. So let's look at how we do it at HPE. This is our philosophy, our manifesto, if you will. So what we do is we basically take an approach in terms of how we implement or how we view QA and developer practices and combine them with the various DevOps techniques. So the first thing is that one of our main QA and Dev work as a single team on the same IDE, and they have a code base and unified processes. Now, we do this to ensure that we can have just continuity across the entire process, right? Because as you know, we have a lot of diverse products that actually help facilitate the testing process. So what we've done is we've allowed each of those R&D teams to define what tools are going to work best within their environment. So it's no specific mandate that says you must use these particular tools in order to implement your testing within Agile or any types of DevOps processes. We let the teams decide, and they could choose to use complete open source. They could use a combination of products internally as well. So we give them the freedom to do that. Also, we have a philosophy that automation is a must from day one. You cannot do DevOps without automation, and we believe in starting that in terms of starting off on the right foot and doing automation that first day. Also, we do include manual testing. As Malcolm talked about earlier, we do have manual testing. However, manual testing is the exception other than for the use of UI validation, right? So we take that mantra of automation first, but we do have manual, but manual is basically an exception to the rule. Automation is our core goal. Also, we don't have any deliveries for QA, so we push to production. So there's no more of this tossing it over the wall, or we're going to wait until everything's perfect before we get it to QA. Again, it's that Dev and QA work as a single team with shared responsibilities across the entire process. And Dev Test, and that's a term that stands for developers, testers, they're not the only ones, but they are what we call the primary advocates for quality along the life cycle. So this role that we have is basically a very skilled developer that is responsible for not only some of the development aspects, but a majority of the testing work that's done. And what they are, they're the primary advocates in terms of how we implement software, how we can make things better within the entire process. So let's take a look at the automation framework. Now, Gasper showed you some of the solutions that we use as well, but this is one that's also for another team. It'll kind of give you an idea of not only all the different types of open source and different types of tools that we use within the organization, but this is a basic example of what a framework can look like, from using some of the cloud resources like AWS and Windows Azure, as well as some of the API testing frameworks for JavaScript, including Mocha and for Node.js. So the goal is, and even though you see this here, the goal is to ensure that our teams have a diverse set of tools that they can use. And again, what we found out that some of our teams actually use trial and error in terms of how they build these automation frameworks. They may try an open source framework that they found that seemed to work well for a certain part of the process, but had some limitations. So they've worked it to where they can actually switch out the different tools within the framework itself. So the goal of this is to show you that you can basically build an automation framework for continuous testing that includes various tools and various reporting information, but you can choose what exactly you want that automation framework to look like. And this will vary from your organization as it does within ours. So I'll just kind of go through this. We kind of talked about this earlier in terms of how we go through this. With a Git master, and we have a release branch. The developer can push the new code. We do the automation. The dev tester, that role that we talked about, can test that new code. And then the dev test team, which is another group that we've created, where again, these are very highly skilled test automation engineers. They are, you'd almost consider them just pure developer types. They work with the popular scripting languages or development languages such as C#, Python, Ruby on Rails, in Java and JavaScript and so forth. So they're very technical, but they can help build that test automation framework and maintain it and be able to do a lot of the fixes, not only fixes to the automation framework, but fixes to the actual code that's being developed as well. And then with that, as we talked about before, they can do the short regression test and push it to production. Okay. So analytics, and this is very important. Kind of go back, jumped ahead. So analytics is very important. One of the mantras that we have is that you can't manage what you don't measure. So we need to have that constant feedback and be able to understand. So how am I able to pull all this information, because we have a diverse set of tools, from commercial to open source, that we need to pull in and be able to understand what exactly is happening real time, right? We don't want to have just static reports that you have to generate at the end of the week. We want live, real-time dashboards and analytics that we can go in and view this information directly. And again, dashboards are your friend. You want to understand what's happening in that DevOps pipeline. How is this code being deployed? Where is it within the actual life cycle? And what's actually happening? And being able to drill down to find out what's happening within these particular environments directly. So dashboards and analytics are extremely important when it comes to continuous testing, specifically within DevOps. So let's talk just a quick summary. The key components: the real-time analytics dashboards, the fast-paced environment, and the QA engineer skill set. I want to touch base a little bit more on the QA engineer skill set. Now, I'm sure attending this webinar, your organization is probably very diverse in terms of the skills of your QA engineers. You may have some that are more business-oriented, or your business experts. Your subject matter experts that are more in tune to the actual whether it's healthcare or whatever the case may be. And you have some years when you're doing traditional testing. And then you have some of those QA who built their skill set on traditional test automation and test automation tools. And some of them may have even dipped their toes into using products like Selenium. One of the things that we realize is that every organization is going to have a diverse set of members within their team, whether they're or traditional. So is when you implement continuous testing is to utilize those skill sets and be aware of how you can actively do them. Now, as I talked about before, we created that dev test team specifically because our products that we're developing are much more complex in terms of the type of end user that we have, right? So we're developing software that helps test other software applications. So with our QA and engineers, we had to make sure that we have a test organization group that's focused on quality, but they still have those skill sets. Now, your organization is going to vary. So what you have to do is really assess where can I best utilize my subject matter experts within that DevOps process and how I can bring them in. So one of the things that you really have to be cognizant of is when you have those diverse skill sets, how can you get it to a point to where you can help some of your test automation engineers evolve, become better test automation engineers in terms of not only just building the frameworks, but having everyone maintain the framework. Because what you don't want to have is a single owns the entire framework across your organization. Because when that person goes and works, someone has to learn it. So the goal is to create and have off the team and make sure that you can increase that. Again, still utilize this to ensure that you can do a lot of that exploratory testing early, but also make sure that you're doing automation first and doing that ahead of time. Diverse one on the same page is the actual goal of releasing this application. And then coding and scripting, and also being able to work independently, right, and taking on some of the new responsibilities. They might even work directly with end users. They may help with any type of defect or bug escalation that may have come from technical support that they now have to do and create that actual bug fix or patch. So you want to have that group start the thinking outside of how they can best contribute to the organization. Then we talked about this before in terms of what that fast-paced environment looks like. But also, one of the main components is getting those analytics and dashboards. Again, you can have the detailed reports, which I think are still needed, but most importantly, you need those dashboards and analytics so that you can monitor real time and be able to pivot and make those changes when necessary. And then understanding your build health. Are you having a lot of these reoccurring problems with your builds? Right? What can you do, or what can the team do to help improve that and to get testing not only just earlier in the life cycle, but to make sure that we have a healthy build or a clean build coming through the vast majority of the time. So with that, I'm going to pass it back to our moderator, and this concludes our presentation for today.
Thank you very much, everyone, for that presentation. Let me just open up my screen here again and just go through one or two more slides with you all. Okay, so the EuroSTAR early bird discount is running out real soon, and there's only a few weeks left to avail of a 10% discount on your ticket. So if you head over to the EuroSTAR site, you can find out all the details there. We also have a even greater discount for groups. So if you buy 4 tickets for the conference, you'll get 1 ticket free. So that's 5 for the price of 4. And this isn't the only webinar we have this month. We have 5 more exciting webinars taking place next week. And we have webinars on thinking through your role with James and John Bach. We have other presentations there with Paul Gerard looking at new model testing. Simon Stewart will talk about the new Selenium 3.0 release and how to use it. Penny Resnick will be talking to you about cloud native applications. And we also have Hybe Schutz who will be talking to you about test strategies using heuristics. So if you want to find out all the information about that, you can just head over to the Huddle site. I have all the links here. I'll just share with you all now. You'll see in your chat box the links to the various offers I was discussing. So now let's have a look at some of your questions, and if you haven't typed a question already, you can do so now. The first question I have here asks how to include performance testing in continuous integration and continuous testing process.
Yes, Gasper speaking. Yeah, thank you for the question. When executing a performance testing scenario as part of continuous integration and continuous testing process, the most important thing is to get a clear pass or fail indication of whether the application's performance has been hit as a result of recent changes in the code. So you need this information without doing any data processing, but just only referring to the service level agreement. So with a few simple steps, you can protect your application from performance regression. First of all, you need to create load tests to run as part of a unit test, component test, or functional test, for example, using add-ins for Microsoft Visual Studio or Eclipse. And then you have to run them as a part of a scheduled or triggered build in Jenkins. There are several plugins that allow you to trigger a performance test as a build step and present the results in the Jenkins user interface. As mentioned before, you have to integrate only scenarios which have a service level agreement, because this allows you to quickly determine whether the test passed or failed and if performance was affected.
Okay, let's have a look at another question that's come through here. And this question asks, how long does it take for the test to run on every commit, and how many developers would work and commit the code?
Hi, this is Clint. I'm sorry, not me, go ahead.
So some of the rules that we typically go by are, for the gated check-in, it's going to be just no more than a few minutes. Once the code gets into a pipeline, we're looking at no longer than 15 minutes to get an indication that your unit tests and component tests have passed. And some of our teams are doing, they're doing a full build after all those tests have completed, and that full build typically will aim to complete it in 90 minutes or less. After that, it's really it's up to the team. We have teams that run builds nightly, and they try and complete their tests in time for the developers to come in the next day and get hold of the status. I think I also mentioned during the talk that something like teams have something like a weekly build as well, which will that's really unlimited. I mean, it's a weekly build because it does take a long time to run the tests, and you could be running extensive performance tests and extensive security tests, which can take quite a long time. So you might not want to limit that. Did you want to add something to that?
Yes. One of the things I want to add is that because we have such a diverse portfolio of tools, which is one of the reasons we have diverse continuous testing processes for Agile and DevOps, meaning that we have some older products that were, that have a legacy code base, but we also have some new and emerging web products as well as SaaS products. So the dev products that you see for some of our on-premise solutions are going to vary from those that have they're going to vary from our SaaS solutions. So that's why when we talk about DevOps and continuous testing, we always try to talk about it from not a one-size-fits-all, because Malcolm mentioned our different teams implement it differently, and they have different processes and different times in terms of how those builds are done, from quick to nightly and so forth.
Okay, let's have a look at another question here. Is there a role for manual testers in DevOps, and should old school upskill?
Yes, there's definitely a role for manual testing within DevOps. Again, one of the things with DevOps, you really want to push as much automation as possible, realistic automation. As we talked about before, manual testing isn't going away. So you're going to have more of that exploratory testing, and you're going to need a certain amount of manual testing just to make sure that you're getting that user experience, which is very important. So user experience plays a big important part with DevOps, especially with the diverse devices that are being used for applications today. You know, rarely is someone just releasing a website anymore. You're releasing it for all devices. So user experience plays a big part, so manual testing is going to become very important with that.
The next question.
I would also add that.
Sorry.
I was just going to add the issue of infrastructure as code as well, and try and put an emphasis on automating any deployments and data provisioning, etc. Anything that can be automated should be automated, and there are things where the return on investment is just not big enough to justify moving to automation. But for repeated tasks like setting up and configuring environments, then there's definitely something that I would advise at least investigating the possibility of automating.
All right.
And also, Gasper is speaking. I would like to add just one more thing about manual testing. And then, if you're implementing a behavior-driven development process, you need to use Cucumber or Gherkin. Gherkin is the language Cucumber uses to define the test. It's a business-readable domain-specific language, and choosing Gherkin tests provide you with a methodology for transitioning from manual testing to automated testing. So this is another way to look at manual testing in DevOps.
Good point.
Will I move on to the next question, or does anyone want to add anything to that? Okay, I'll move on to the next question here. This question asks, if you have a test team that works only during the day at the same time as the dev team, how do you minimize the time that the dev team is waiting for test results and avoid idle time?
Well, I think it really depends on the organizational structure. So again, if they're working as one team, there really isn't this idle time. There's always going to be something where the testers should be working on, right? So they're going to be developing, they're going to be maintaining, they're going to be tweaking those automated tests. So there should be this continuity between not only just within the process, but the teams themselves. So what you don't want is to kind of revert back and have, and many of you probably heard these terms, the water scrum ball type aspect to your continuous testing process. What you want to do is make sure that you're embedded in every single part, from those developers that are creating those unit tests, and you're developing those UI tests and API tests, but there's always something going on. There's a level of refinement, there's a level of review that to where there isn't an area where anybody should have any significant downtime within your organization. So I think the first step would be just to kind of maybe back up and kind of evaluate to see if you are getting that dead time, what's exactly the root cause of that within the team itself.
We might take one more question here, as we've just gone a little over the hour now. This question here asks, how long does test automation suites take to give results?
So again, I think we answered that in one of the previous answers. It depends on what the aim of the test is. If it's a very quick test to validate that the code is fit to enter the pipeline, then it's going to be a quick test, completing within a few minutes. If you're going to be doing an extensive regression test plus full security tests and performance test scenarios, then you could be looking at many hours, sometimes even days, to run full test suites. So it depends what you want to accomplish. But I think the key point that we've seen throughout this presentation is that you want to start with very short and very quick tests, and then gradually move up to longer running tests, because you don't want to be waiting a week just to find out that your software doesn't compile. I mean, that's a bit of an extreme example, but the point being that the sooner you get results, the better. So you want to break your tests up into small, short-lived tests and run those first. And only once all those tests have passed, start working on your longer running and more complex tests.
All right, that's all we've time for today. I'd like to thank our three presenters, Malcolm Isaacs, Clinton Sprov, and Gasper Marino, for taking the time out today to present this webinar. And I'd like to thank all of our attendees for coming along. This webinar is being recorded and it'll be available over on the Test Huddle site very shortly. So that's it from us. Thank you all, everyone, and take care.
Thank you very much.
Thank you.